This revision video is going to be on coding and how we code data and how we can calculate the standard deviation and mean of a coded set of data. So we are given a question here that says the scientist measures the temperatures X at 5 different points in a nuclear reactor and her results are given below. So the original data we've got 332 degrees Celsius, 355, 306, 317 and 340. Part A is asking us to use the coding y equals x minus 300 over 10 to code this data. So to each piece of data we're going to subtract 300 and then divide it by 10. 332 subtract 300 is 32. 32 divided by 10, that's 3.2. 355 subtract 300 is 55, and then dividing that by 2 we get 5.5. For this one we get 0.6, 1.7 and then 4.0. For part B, we're asked to calculate the mean and standard deviation of the coded data. So of the coded data, the sum of our coded data, we just need to add each piece of data here in that bottom row. That is equal to 15. And the sum of y squared, we're doing 3.2 squared plus 5.5 squared plus 0.6 squared plus 1.7 squared plus 4.0 squared, which is 59.74. So these are the two pieces of information we need to calculate the mean and the standard deviation. For the mean, we denote that as y bar. That's equal to the sum of y over n. So we've got 15 over, and we've got 1, 2, 3, 4, 5 pieces of data. So our n value is 5, and that's equal to 3. For the standard deviation, we're going to first of all find out the variance. So sigma y squared, that's equal to sum of y squared over n, subtract sum of the y values over n, all squared. So this is equal to 59.74 over 5, subtract 3, all squared, because that is the value of our mean, which is equal to 2.948. So then the standard deviation of our coded data is just the square root of 2.948, which is 1.72 to 3 significant figures. For part C of our question, it says, use your answer to part B to calculate the mean and standard deviation of the original data. So we're going to use our coded formulas. So for y bar, we get the y bar is equal to x bar minus a over b. So our value of y bar was 3. X bar is what we're finding out. Our code was y equals x minus 300 over 10. So our value of a is 300, so we're going to subtract 300, and our value of b was 10. So we're going to, first of all, we're going to rearrange this to solve the equation, find out what x bar is equal to. We're going to start by multiplying each side by 10, so we get 30 is equal to x bar, subtract 300, and then add in 300 to both sides. We get that x bar is equal to 330. For our standard deviation, we know that sigma y is equal to sigma x over b. Sigma y, that was 1.72. That's equal to sigma x over b, which is 10, which means that sigma x is equal to 1.72 times 10, 17.2. And these, are both in degrees Celsius. And that was 3 significant figures. For your second guided practice, we're given that from the large data set, the data on the maximum gust, G knots, is recorded in Leutches, not sure how to pronounce that word, during May and June 2015. The data was coded using H is equal to G minus 5 over 10, and these statistics were found. We're asked to calculate the mean and standard deviation of the maximum gust in knots. So we need to decode our data. So we know that H bar is equal to G bar minus 5 over 10. G bar is what we want to calculate. That is our mean of the maximum gust in knots before it was coded. So H bar, we're given that's 2. G bar, subtract 5 over 10. So we're going to multiply both sides by 10, and we get 20 is equal to G bar minus 5. Add 5 to both sides, and we get G bar is equal to 25 knots. So that's our mean. Our standard deviation, well, we are given this value SHH. Now, from when you learnt about variance, you saw this formula here. So the variance of a set of data is this value SHH over n. So first of all, let's actually calculate our standard deviation of the coded data. So our variance of the coded data is 43.58 over n, which is 61, which means that our standard deviation is going to be the square root of this, which is equal to 0.845 and so on. So we want to find the standard deviation of G. We know that the standard deviation of H is the standard deviation of G over n. So we've got 0.845 ... is equal to that standard deviation that we want to find out of the data before it was coded, and dividing it by, not by n, it's divided by 10. It's that value of b when we've been coding it. So I'm just going to change that to b. We're dividing it by 10, which means that if we multiply both sides by 10, standard deviation for G is equal to 8.45 knots. So 3 significant figures.